My name is Fenn. I'm the president of ITRenew, and I am very happy to be here with you all virtually. I hope everybody is healthy and safe and doing well in these crazy times, but glad to be connected at least in this way. So today we're going to talk about a thesis and our thesis for a transformation to a circular IT hardware industry, and specifically the financial and sustainability opportunities of doing so. ITRenew is in this business. We are 100% circular. We are orchestrating this transformation to a global circular IT hardware industry, which means that as compared to a traditional linear model where, you know, we would take things, make things, and then dispose of them in some way, the thesis of a circular economy is that we instead cascade assets or things into as many loops of life as possible to maintain their highest utility value as much as possible. So a circular economy is not, you know, wasteful and disposable. It's regenerative by design, and it keeps assets as high in their highest utility value as long as possible. What that means in our context is we work with hyperscale cloud companies. We decommission their equipment. We transform that equipment into solutions for global markets. So we're extending and maximizing the lifetime value of that equipment. And we do that with a series of products and services that become the connective tissue for this whole circular model. And we're going to talk, as I said today, about the financial and sustainability imperative to doing this, and for us all to get behind this transformation, and then also with the opportunity that exists if we do it well. So let's start with the hardware. We're talking about IT hardware after all, right? It's an OCP event. And frankly, this motion to a circular economy is all about the hardware. So the context that we're operating in is massive and unprecedented scale, right? We're spending, on track to spend over $200 billion by 2023, according to Gartner, on data center hardware, right? This is just the compute and storage that goes into data centers, right? A third of that goes into hyperscale data centers. And those hyperscale data centers data center operators are refreshing their equipment every 3 to 4 years on average. So it's a very fast, unnaturally fast almost, refresh cycle that causes significant churn and refresh of hardware, which, as we'll see in a moment, is very, very expensive. But it's also not just about hyperscale, right? This industry, as I said, is going to be more than $200 billion soon. And it's about 50-50 mixed between enterprise and cloud. So this pertains to everybody who's running data center infrastructure, both hyperscale, mid-scale, and lower scale, the global markets truly. And this is the stuff that powers the compute that we all rely on in our personal and professional lives globally, right? So it matters financially. These are big, big numbers. Now, if I put that in context of the other data center costs, right? So hardware as a portion of data center TCO, this is a model that we've worked on with several of our hyperscale partners to really understand the cost of running a data center. And this is a 10-year view. And you can see that overall costs increase, of course, as these hyperscalers grow, but that in all cases, the IT hardware portion of TCO is about 75%, which means that everything else, power and infrastructure to run the data center, even including facilities cost, is a much lesser component. So this is a spotlight on where we need to look in terms of driving incremental efficiencies from a financial perspective, right? So there's really good motivation financially to think about new models. Now, on the flip side, if I look at the sustainability context, right, you know, this industry, the global tech sector, is phenomenal and is powering some of the most positive impact in the world, solving some of the most important problems. But candidly, it's also on a bit of a dangerous trajectory, right? We have forecasts that say that we are going to consume by 2040 more power than is produced globally, just in the data center industry. We have e-waste coming out of the global communities. That's nearly 50 million tons annually. To put that in context, that's 18-wheel trucks stacked front to back from New York to Bangkok and back, full of e-waste every year. There are some people saying that we're going to run out of the materials that we need to mine to make components, and that we're going to have to turn to deep seabed mining for this stuff. Seems like a really, really bad idea. Things like AI, which have such immense potential and powerful positive potential, are energy hogs, right? They're forecast to consume more than 10% of total global electricity within the next couple of years. So this is and candidly, the technology sector, digital in general, is kind of on the wrong pace. It's growing from about 4% by some forecasts today of total greenhouse gas emissions on a track to go to 8%. So where other segments of the industries are pulling back emissions, and we're on the wrong track. We're becoming an outsized portion. So this means we've got to start thinking about how to harness the positive potential, but also curb the negative potential of the industry. When I look at hardware, data center hardware in particular in the environmental context, these are some Gartner numbers, right? So we have 65 million servers currently. This is as of August 2019, about 65 million servers deployed globally in data centers that have an average of 50 racks or more. And between 2019 and 2023, Gartner expects that about 14 million servers a year are going to go into those environments. So that should get us to 121 million. That should be simple math. But it turns out that the end deployed amount in 2023 is only 75 million, which means that nearly 50 million servers are going to be end of life and coming out of those data centers over the same time horizon, right? So back to the context of e-waste, right? This is an insane amount of hardware, and we are collectively responsible for thinking about handling it better. So good news is there's an answer. We think it lies in moving the whole industry to a circular data center model. So we talked about this a little bit before. It's cascading loops of life. In this context, if you start at the beginning, it's thinking about everything from design of hardware to make sure that we're designing it with maximal lifetimes in mind. It's working with hyperscale companies who do these for very good reason, fast refresh cycles. But it's working with them to then figure out how do we maximize the mix of kind of circular pathways post the end of their first use. And in some cases, sort of lower left-hand corner here on the slide, that means facilitating an internal reuse pathway, which is very valuable, right? No disassembly, no remanufacture, very little logistics. If there's a secondary workload that is ripe for outbound equipment, then that's a great first pathway to choose. The second one, and we're going to focus a lot on this today, is that you can take rack scale solutions, and instead of doing what people used to do at the end of a first life, which was harvest things for components and recycle the rest responsibly, let's consider that a least worst alternative. And instead think, can we take rack scale solutions and move them into other markets as complete rack scale solutions? So again, keeping those assets in their highest utility value, as little kind of remanufacturing or energy input needed to cascade them into the next life. Secondly, for things that are still requiring compute and storage, but not in rack scale form factors, there's also a huge opportunity to be more circular than we've been in the past. And that's very specifically edge, right? So there are some forecasts that say edge is going to be 4 times as much infrastructure as cloud, massively distributed footprints in all sorts of locations. This is a great destination for hyperscale technology that's proven and very early in its relative total lifetime to be able to be cascaded into other lifetimes. And of course, then if we can't do those two things, then of course we recertify and sell components that are valuable to a variety of secondary markets, and always responsibly recycle the residual, right? So if, again, in the old world, a linear model, a hyperscaler might take equipment and use that equipment and then responsibly handle it at end of life. Now we have all this multitude of pathways that we can deliver with real products and solutions in the middle. And they feed broader global markets like telco, gaming, cloud service providers of lesser scale, retail, enterprise, and so forth. So that's the thesis. Now, I want to go back to the financial opportunity here, and starting with the hyperscale perspective. If you think about those various pathways I just described, right, they're now focused in on this slide. And in the traditional model, you might have done 0 internal reuse, 0 remanufacture as rack scale solution, recertify as rack scale solution, 0 edge, but you probably did a pretty good job, as the industry has been doing for a number of years, of selling about, selling at least the components from about 95% of your equipment, and then only having to recycle the residual of that, right? So I call that like a 0, 0, 0, 95 mix. Now, if you move to a mix where you're actually able to reuse a certain amount, or in this case, not reusing any, but just for example, 30% goes into the markets as rack scale solutions, 30% goes in as edge solutions, and then you're down to 30% as recertified components. The impact of that for a data center, that's a hyperscale data center that in this case starts with a base of 2 million servers, refreshes every 3 years, and is growing their compute capacity at about 30% per year with logical Moore's law assumptions, power assumptions, and so forth. The impact to total cost of ownership over 10-year horizon is nearly $7 billion. So these are very, very real numbers. And of course, there are a lot of companies operating at this scale. So if 10 hyperscalers did this, that's nearly $70 billion of potential increase to the value recovery that's possible in moving to and creating a circular economy, right? So again, what this is motivation on the part of the hyperscalers to help all of us achieve this transformation. Now, on the flip side, like where does that equipment go? If we turn it into racks, where does it go? Well, it goes to downstream global markets. That's the right hand, left hand of this, right? It has to be matched somewhere. And it turns out that those markets are much more blocked and constrained, right? So a couple of examples, right? Mid-sized banks spend about 50% less as a portion of total expense on R&D and on technology as the mega banks do. And so that puts them always at a hamper. Not only are they lesser scale, but they're able to spend less as a proportion to be able to compete better, to be able to make their budgets go further, to be able to innovate and so forth, right? So they're constrained by budgets, right? The hyperscalers are less so. Increasingly, especially in the era that we're living in right now, budgets are increasingly constrained, right? At the same time, you have data creation just exploding, right? So 13.6 zettabytes is forecast to be just the enterprise data that's created and needs to be stored. That's $1.5 trillion of spend at current storage economics, even assuming, you know, Crowder's law changes and so forth. And that's a huge gap. Enterprises don't have that much money to spend on IT. Lastly, importantly, part of this is, and we'll come back to this in a bit, but part of this is really about, you know, the global opportunity, including the developing world. And it turns out that the Sustainable Development Goal that the UN has for universal access, where every person gets online, which today means, today there are only about 50% of the people globally are online. If everybody got there, the spending required, there's still $100 billion gap in information and communications technology. Now that's not all IT hardware, but again, if it's even 30% of that spend, it's another $30 billion of gap. And so there's motivation on the downstream side of this also to say, can we be more economical? Is there a better strategy here for total cost of ownership and for maximizing the lifetime value that helps us in our pursuits downstream? And it turns out that when you compare circular hyperscale equipment coming into the market compared to traditional OEM, much more expensive proprietary solutions, that it is very possible to unblock some of those markets to make budgets go much further. This is a case where we have compared our circular solution Sesame compared to a very standard OEM solution. This comparison includes a greater number of cores in the circular case, a greater amount of memory in the circular case, a greater amount of storage in the circular case, and it includes fewer racks because of the higher density afforded by OCP specifically. So you have a better performing solution, you have a better characterized solution, and even when you include a 60% discount off OEM hardware costs, you're still 41% better in this case, right? So very meaningful impact to the global budgets, whether you're a telco, an enterprise, a tier 2 or tier 3 cloud service provider opportunity here. And people often ask, well, that's fine, but isn't public cloud just more efficient anyway? And the truth is, in some cases, yes, especially at small scale, but in many cases, no. And of course, this depends on utilization, it depends on egress, it depends on a number of factors, but this is a common scenario that we encounter in the kinds of customer engagements we're in. And you can see in this case that the circular option the proven hyperscale technology that's coming out of these data centers and being made into circular solutions is less than 30% of what a similar workload would require in a public cloud instance. So now we clearly have a financial context that drives motivation. We have opportunity for both the very large hyperscalers as well as the downstream markets to think about this as a financial opportunity in moving to circular. But what about environmental? So ITRenew recently did what I think is some very interesting research on quantifying the net CO2 impact of a full OCP compute rack and the impact of moving to a circular model. The first part of this was look at the life cycle of everything that's involved in a rack life cycle, from the mining of materials to mining of minerals to the creation of manufacture of components, assembly of systems and racks, through the use phase, running equipment in the data center, and then across the end of life process of sorting and shredding and smelting and so forth. And it turns out that in a very common construct where minerals are mined in various parts of the world, components are manufactured in Asia, assembly is done in Eastern Europe, and the data center is running in the Nordics, it turns out that before you ever turn this thing on, you spend nearly 75% of the total carbon impact, right? So it's a massive portion that's associated with mining and manufacture of equipment, and it's significantly greater than the use phase energy, which we've all been very focused on for the past decade, and importantly so, right? This is the focus of renewable energy. Decrease your carbon impact of running the data centers. We see this in focus on PUE, we see it in focus on moving to renewables, and all of that is essential, but it's not the end game, right? We have to look next to this massive embodied content, which reflects the pre-use and the post-phase of the total impact of our equipment. So the next phase of our analysis was, knowing that the pre-use phase matters so much, what if we could enable a second life? And it turns out this is what it looks like this is the visual representation of what I just described. You see orange is the largest portion of the CO2 impact in the base case scenario, and the operational energy is a smaller portion. But if we can move to a circular model and enable a second life where we're deferring all that new manufacturing, then we get a net impact of nearly 25%, or the equivalent of getting another 68% out of our operational phase. So this is, again, a great way to enable secondary lives, have a massive impact on the net CO2. And of course, the next question is, well, if it's more sustainable, isn't it going to cost me more? And we talked about the hardware level, circular versus OEM system before, but at the system level, total TCO of the system, you also see a 24% savings in moving from a linear model to a circular model. So, and everybody benefits in this, hyperscalers and downstream markets. So now the question is, it makes sense from a financial perspective, makes sense from a sustainability perspective. What does it take? Well, the good news is it's totally happening now, right? We are doing this. ITRenew is doing this today with hyperscale partners and with the downstream markets. And frankly, OCP is at the core of it all, right? So this whole thing depends on open. It depends on open hardware designs that can be supported and warrantied and reconfigured into global relevant solutions. It depends on things like open systems firmware, which are essential, again, to us being able to support things and transform them and upgrade them in the secondary markets. It depends on a global operations and logistics footprint to sort of create all this connective tissue. And it depends on significant hardware and software engineering to be able to take systems that were designed for very specific hyperscale technology environments, designed by some of the best engineers in the world, but not necessarily relevant to the broader set of use cases. So you have to invest in being able to turn the hyperscale model into models that are useful and accessible for all, right? And again, one of the key tenets of OCP, but that's what we're trying to do here with circular, is make this best-in-class technology accessible to all. So it's services, it's products, but it's also, very importantly, we all have to get on board with this. It's the right thing to do from a financial perspective. It's the right thing to do from a sustainability perspective. And we need to adopt a shared ethos and get behind it together, because it takes all of us working together. So the connective tissue, what does it look like in action? Well, it looks like Sesame by ITRenew. So we've talked about rack scale solutions. This is proven hyperscale technology. It's coming out of these environments at immense scale. So we can have, for the first time, we can have the highest quality, stable, no compromise, warranted kind of equipment. Downstream markets can depend upon it reliably at scale, so they can plan their infrastructure roadmaps on it. And again, it's at breakthrough TCO, which is what unblocks budgets globally for IT and lets us all compete better and do more with our dollars. Now, importantly, and this gets back to OCP for all, right? Optimized for your workloads and ready to deploy. It's a super, super important point. So we have systems, rack scale solutions that are designed for Kubernetes and container environments, designed for virtualized environments, designed for AI and ML, and designed for converged environments, because the rest of the world does not have the engineering resources of the hyperscalers, and they need software certifications. They need some reconfiguration. And that's what we've done with Sesame, so that it makes it truly easy to bring OCP into the broader markets that have not yet been able to realize the gains and the TCO advantage and the efficiency advantage that some of the largest players in the world have had. So that's me talking about it. But I want to also bring up David Rowe from Hydro 66 to share his perspective on what's important about, from a sustainability perspective, from a circular perspective. So David, welcome, and thanks very much for joining me today.
Thank you, Ali.
So David, I just thought we'd do this sort of informally and have a few questions. I'm curious, just to set context here, can you just introduce a little bit about Hydro and tell us what you guys are up to?
Sure. So we have built a purpose-built data center up in the north of Sweden. And the original premise was to try and push the limits of low emitting carbon footprints. The location clearly benefits from low ambient temperatures, so less cooling required, therefore less energy required. It's 100% hydro powered. But equally importantly, the power in the region, which in the river next to our data center is something like 4.3 gigawatts of power, which is kind of a really big number. That is not utilized in the area for industrial use, so it's spare. We are very keen, and it's part of our DNA, to lower CO2 in this field. It's also important to recognize cost, because I think a lot of people think that cost and low carbon emission or having green solutions are kind of not synonymous with each other. So we were trying to change that to look into the hardware side of things as well. So this is where Sesame comes into the picture. We're super excited to be working with Sesame. We've got the same mindset. And we're looking to be disruptive, because in some senses only crisis causes change. But if you're able to start with a blank piece of paper, I think you can get ahead of the curve. So that's what we're trying to do.
The challenge is that big, right? We need to bring the best thinking and innovation to all the elements of both driving down costs of infrastructure and maximizing sustainability, because we're collectively operating at a scale that's just untenable otherwise, right?
We also have our own plans for launching our own public and private clouds within our data center and other facilities. And one of the test products that we're hoping to launch soon is something which is more along the lines of artificial intelligence, machine learning, hypercompute, which relates to solving some of the complex equations around protein unfolding, which obviously is important and very topical at the moment with COVID and so on.
You mentioned COVID. Obviously, it would be strange for us not to touch on it all here, given the context. How are you thinking about the consequence for data center infrastructure and in the context of COVID going forward?
Whether people are staying at home or whether it's just the inexorable growth of data, compute, AI, ML, all the things that you mentioned in your piece. The next thing, of course, is that more businesses will depend even more. It's a trend that's been going on for a while anyway, but it's only set to accelerate, I think, which is that your business is your IT. It is what's in the cloud. And you're using smarter and smarter tools to get better efficiency. Therefore, it becomes a bigger and bigger slice of the pie of cost in your business. So those two twin things of crisis in climate and crisis in the economy are only going to increase sharply the focus of businesses in looking at solutions that, between the two of us, Sesame and Hydro 66 and others, of course, are going to be providing.
Yeah, I would agree. Obviously, these are strange and unprecedented times, and have some very serious challenges ahead of us. But I do think that it's going to be ever more important that we think about rebuilding in sustainable ways, and that we do so most cost effectively. And there will be rebuilding, and there already is, and it is increased demand on IT infrastructure. So hopefully we can move forward with the transformation and help everybody get back to business. I guess last question: what's most exciting to you about sort of the future of this next chapter of data center innovation?
Well, I think it's the idea that it becomes mainstream. Now, we've seen already to an extent that in Europe, for example, the vast majority of data center builds and server co-location has traditionally been in the kind of city centers, Paris, London, Frankfurt, Amsterdam. Now, we know that they're actually running out of power in these regions. So, for example, Amsterdam, there's a moratorium on any new data center build. There's real issues there with the climate lobby. But along come the sort of hyperscalers, Google, Facebook, Amazon, Microsoft, etc. And guess where they're building? They're all building up in the north of Sweden or in the Nordics. So it's kind of creating almost in a natural, automatic way, the center of the data sphere, if that's a word, is shifting up to the Nordics and creating a kind of Nordic super cloud, because it's highly scalable, whereas it's not in the other regions. And the climate issue is a big thing.
Great, thank you. So I guess I'll just close up with if you had to summarize, obviously we're here talking about circular, we're talking about Sesame, we're super excited about it, we're super excited about the partnership with Hydro 66. If you had to summarize Sesame in a sentence, how are you guys either using it and most excited about its potential?
Well, we're using it to address the issue of driving costs down. And that means that our end users will benefit from that, be they co-location customers, cloud customers, infrastructure customers. And there are very few people out there that are able to do this at scale. And Sesame is one of the few people, because partly through their history, that have landed on their feet in this space very convincingly, I think. And we're really looking forward to developing the relationship with Sesame, buying more stuff from Sesame, driving the cost of ownership to customers with Sesame. And the fact that it is part of the circular economy is as good as it gets. So this whole concept that you have to buy new each time, we're really talking about a utility where the customer is paying, it's bang for buck. So like for like, we think that what's coming out of Sesame, there's no reason why that can't be a leading proposition for customer requirements. So you put all of that together, and I'm really excited about working together with you.
Thank you so much, David. I really appreciate you joining me, and I really appreciate the collaboration, and we look forward to all of that in the future as well. So thank you very much for joining us. I just want to conclude with a couple of key takeaways, right? Our thesis, and we are absolutely seeing it, is circularity is both a massive opportunity and it is an imperative, right? We all must work together to transform and really harness the full power and limit the negative byproducts of our industry. And we're excited that Sesame is a big part of the answer to that. We are taking it to market with real world TCO smashing benefit in a very sustainable way, bringing hyperscale technology sustainably to the broader markets, and able to leverage our global operations and logistics footprint, which gives us a huge opportunity to do this at the scale required very, very quickly and very effectively. So I guess I would close with a challenge to everybody. Our hypothesis is that the time for 100% circular is now. So thank you very much.
Right, I think I'm live now for a minute or two to answer some questions here, just very quickly. So thanks everybody for joining today. The question that's in chat, yes, the answer is Hydro 66 is using the circular economy equipment. That is, all of the Sesame equipment is circular. It is the proven, recertified hyperscale technology. So the answer to that one is yes. The other couple questions I got in separately are, where did the financial analysis and the sustainability analysis come from? The financial analysis comes from deep collaboration with our own data science teams and the teams of our hyperscale partners and also our downstream customers. So collaborations across the ecosystem. And the sustainability analysis comes from both ITRenew data and a very comprehensive life cycle analysis that leveraged data sets and analysis from about 60 independent academic and industrial journals, as well as independent third-party verification and validation. So we really sought to bring very robust data to back some of these assertions, because it's obviously a new model. The second question is kind of, where is the best fit for this, and is it really happening? And the best fit is the customers that are moving sort of their consideration of the solutions they need into places that are very performance driven. So in other words, what is my workload need? What is my specific environment need from a utility perspective? And I don't care so much about the piece parts. I care that I get the end benefit that I need, and I'm able to deliver the service that I want to deliver at the most attractive possible cost and without compromise in other areas. So certainly there are always people out there who are very focused on specific part numbers, and in some cases absolutely rightly need the absolute leading edge stuff. In the majority of cases, we're definitely seeing a shift in the market to people who are thinking most about kind of performance per dollar and how do I get exactly what I need, and I'm okay to use a flexible set of building blocks on that. So it is very much happening. It is very relevant for the majority of, or a majority of, very common cloud kinds of workloads and across the industries that we've talked about. So hope that's helpful. And again, thanks everybody for joining.